Alright, so let's take a close look on what an if block is. A lot about making codes is writing instructions like we do with the methods. Okay, so we have a start method where we change the name of the cube. We have an update method that is going to change the size of the cube while the game is running. And we made a method that, well, improves a string that we put here, for example. But sometimes we have to check for certain conditions, to check if certain conditions are met. So for example, in a first-person shooter, a player could only fly if they have a jetpack equipped. We can only buy a certain bicycle in our game if we have enough money. Okay. So, for example, we can only enter a dungeon if we are in the level 50 or more than that. So, several times, okay, lots and lots of times, every time, in every game you can imagine, you are always asking questions. Okay, the code is always verifying, comparing things, comparing numbers to see if these things are true. Okay, so a quick way that we can learn how to use an if block is just go to our start method. And we're going to type here if. We're going to open and close parentheses. Then we're going to open and close curly braces. Okay, so this is an if block. And whatever we put here between parentheses is going to be our question. So for example, we can ask if 1 plus 1 equals to 2. Notice that different from the assignment operation where I use only one equal sign, we are using two equal signs. So we're going to compare if whatever we have to the left of this sign is the same thing than what we have to the right. So we're asking if 1 plus 1 equals to 2. If this is true, then whatever we put in this scope definition here, so between these curly braces, is going to be executed. So I'm going to type here debug.log, and we want to print a simple message. Okay, so we open and close parentheses, add a semicolon, and now we're going to add the string "we are here." Okay, so we can save this, and if we go to Unity and wait for this compilation to be complete, we're going to press the play button, and after we do this, we print the message "we are here." Okay, so it's right here in the console. It means that whatever we put there is true. But what if we ask for something else? What if we want to ask if the string cats equals to the string dogs? Okay, so we're comparing two strings in here. We want to see if they are basically the same. So if we save this and we go to Unity and wait for this compilation to be finished, if we press the play button, okay, notice that nothing appeared in here. And better yet, there was something very interesting. Let me just recompile this code again. Once the compilation is finished, we have a warning. Okay, so it says here, at the line 14 of the cube script, we have a warning called Unreachable Code Detected. Why does this happen? It happens because we are adding a comparison in here. We ask if cats equal to dogs. But the compiler already knows that this is never going to be true. There is no way, okay, it's not possible that it is going to be true at a certain time. Better than this, internally, once the code is being compiled, it's automatically converting this to false. Okay, so whatever we put between curly braces, it doesn't matter how many lines we add here, this code is unreachable. Okay, it's never going to be executed. So what if we add here can't be executed? Okay, so let me come back here. Okay, so we have cats equal to dogs. What if you want to execute something only if what we put here is false, so it's a lie? We could add here another line. So we could add another instruction, so we could just add an if block, and we could ask, for example, if cats is different than dogs, for example. Okay, so this is what we need to do to ask if something is different. This would work. Okay, so we can type debug.log, we're there, for example. So if we save this and go to Unity and wait for the compilation to complete, we could press the play button once more. Okay. So we press that and we have the "weird there" message. Okay, so we successfully see that this is a true statement. But there's another way to do this. Instead of adding another if block to check if the opposite of what we added here is true, we can just add the else keyword. Okay, so we open and close parentheses and we can type here debug.log. Let's say here this is false. Okay, so here we can add it's true. And here we can say this is false. Okay, so or just it's false. Okay, so that's pretty much what we need to do to understand a few conditions. So we can compare things like this. We can compare if things are equal. We can compare if 50 is greater than 10, for example. There are different things that we can add. We can compare if 32 is lesser or equal than 40, for example. We can do all of these verifications here. But for this game, we just want to ask if is rotated equals to true. Okay, we don't want to check anything else. Even better, since is rotated is a Boolean variable, we can even not add this here. We can just type if is rotated, because this is already something that is going to return either true or false. And if this is rotated, we want to change the rotation of the cube. So to do this, we're going to type here transform dot local Euler angles equals to vector3.1 multiplied by 45. Okay, it's basically going to tilt the cube a little bit on all of the three axes. Okay, you don't need to understand the details of this, but anyway, we reach the transform component. We are accessing the local Euler angles property, so we can set the rotation of the cube in Euler angles, which vary from 0 to 360. And we're saying that it's going to be 45 on X, Y, and Z. And if we save this and go to Unity, and if we wait for this compilation to complete, we can press the play button and notice that nothing happened. This is the behavior that is going on here because we started the game with is rotated set as false. Okay, so the check mark is unmarked. But if we come here and mark this is rotated and press the play button, now the cube is tilted. Okay, so it successfully changed the rotation of this cube by just marking this little checkbox in here. Okay, so with this we can already work with rotating the cube. Okay, to work with if blocks. Alright, so now that we have this, we took a look on some nice, interesting concepts on coding in C# and for Unity in general. So another thing that is going to be very powerful is to use loops. Okay, so when we use loops, we can perform an operation several times. Let's understand how to do this in the next video. Okay, so for this exercise, imagine we want to have multiple cubes in here. So imagine we want to have 2 cubes. We can just get here, duplicate the cube that we have and move it to a different position. And we can just press the play button and we would have 2 cubes in here. Okay, but what if we want this to be modified? Okay, so without having to manually set it here, what if we want to just have a game object and we can say, hey, we want 10 cubes, we want 50 cubes to be in this game. Is there an easy way to do this? And yes, there is. First of all, we want to transform this cube that we have here in this game in a prefab, so this can be easily reused later. So to transform this into a prefab, we can just drag this cube and drop it here in the project window. Okay, so we have a cube prefab. It's like a saved instance of our cube. Notice that the cube is now blue because that means it's a prefab instance, and we can already come here and delete it. Okay, we can completely remove it from the scene because we're going to dynamically instantiate it later. Now, who is going to be responsible for adding these cubes? We're going to make a new game object that is going to control the rules of this game. So we're going to right click here, select create empty, and with this game object selected, we go to the inspector, and this is going to be named game controller. Okay, let's hit enter, and the position is going to be 0, 0, 0. So it's going to be in the center of our scene, in the center of the world. Now we're going to make a script for this game controller. So we right click in the assets panel, select create, and then C# script, and we name it game controller. And now, as we saw in the first and the second video, to apply this script so it can be executed, we need to select our game controller game object and just drag and drop the script in here. Okay, so whatever we add in this script is going to be executed. And now we can double click so the script is opened. Okay, so we have the definition of the class, we have these using instructions, we have 2 methods here, and now we need to have a reference to our cube prefab. So to do this, we need to declare a variable. We're going to type here public game object cube prefab. And if we save this and go to Unity, notice that this is going to behave a bit different than the variables that we used before. Because in the cube prefab right now, we have three variables. We have size modifier, which stores a floating point number. We have new name, which stores a string. And we have isRotated that stores a Boolean variable. It's either true or false. But for the game controller, it's storing a game object, and better yet, it's storing a reference to game object. So we need to inform this cube prefab what object we want to use. So we can just select our cube prefab here. We can drag and drop it here. Okay, so the binding is complete. It means that the cube prefab variable that we have in our code now holds a reference to our cube prefab. Okay, so let's go ahead and instantiate one cube. We're going to use the start method for this. To instantiate a cube, we can simply type instantiate and pass cube prefab as a parameter. We simply do this method call. We say instantiate and we pass cube prefab. Now we can save this. We'll go to Unity and wait for this compilation to complete. And after it is done and we press the play button, you're going to see that there is exactly one cube in this game, in the position 0, 0, 0, with the size modifier 2.5. Let's also reduce that. Okay, let's use 0.8 in our prefab, and then it contains this name, cube 42. Okay, so let's stop the scene. Let's go to cube and let's change the size to 0.9. Okay, so now that we press play again, we can see one small cube here. But what if we wanted 10 cubes? Okay, it would take a lot of time for us to just duplicate the cubes and position in several different positions. So how do we call this different times? Okay, to do this we need to use loops. There are uncountable usages for using loops, okay, but this is going to be one of the most basics of them. Okay, we want to perform a certain operation 10 different times. To do this, we're going to write this block that I'm going to type right now, and later I'm going to explain what's happening. So we're going to type for, we open and close parentheses, and we open and close curly braces. We're going to type int I equals to 0, then a semicolon, I lesser than 10, semicolon, I plus plus, and I'm going to move this instantiate instruction to be inside this for loop. Okay, so what's happening here? In this place, we're initializing this loop, so we're using a variable that we very commonly call I, and it starts as 0. So this is basically going to work like a pointer. It's like an arrow that is going to hold the current position where you're at. Okay, and this is the condition that needs to be met for this loop to continue happening. Okay, so in the beginning, we declare an integer called I, so it's just a simple whole number that's going to store 0, 1, 2. Okay, then we verify if this condition is met. So 0 is lesser than 10? Yes, it is. So once this happens, we enter this scope here and we execute whatever instruction we have here. When this ends, whatever we put here is going to be executed. So basically we increase the value of this I variable. And after we do this, we continue the loop in this position. Okay, we check if the new value is lesser than 10. So we have 1 lesser than 10. Yes, this is true. We instantiate another cube. We increase one more time. 2 lesser than 10. Yes, and then I is going to be 3, 4, 5, 6, 7, 8, 9. And once it reaches 10, it's going to see that this is false. And when this happens, it's going to exit the loop and do whatever other things we have here. Okay, so if you save this script and you go to Unity and wait for this compilation to complete, okay, just a few seconds, and if we press the play button, you're going to look at the hierarchy that you have 10 instances of the prefab that we created, okay, 10 instances of QB42. But the problem is they are all in the same position. What if you want to change it to be in a random position? We can just store whatever comes out of this method. Okay, instantiate is not void. It returns the original game object, the instantiated game object. So we can type here game object and type cube object equal instantiate cube prefab. And now we can set the position of this cube object. So we can type here cube object dot transform dot position is going to be a new vector 3. So we're going to build a new vector 3. We need to pass 3 values here. We need to pass x, y, and Z. So the horizontal position, the vertical position, and the depth position. And to get a random number, we can just type here random.range, and we need to pass the minimum and the maximum values. I'm going to use minus 10f as the minimum value and 10f as the maximum value. This is for x. We do the same thing for y, so minus 10 and 10. And for z, we're going to use 0. Okay, so let's save this and go back to Unity. And after the compilation is finished, we can even move our camera back a little bit more, so minus 10 here. Okay, it's going to be like this. And this time, if we press the play button, you're going to see lots of different cubes in here. Okay, so we have 10 different ones. Okay, maybe the range was a bit too wide, so let's improve this code. Okay, we have a few hard-coded settings here. The number of cubes is hard-coded, and the random range where they spawn is also hard-coded, so we can change this. We can type here public int cube amount, and let's start with 10, and also public float random area. Let's use 10f here. Notice that cube amount is an integer number, so we just type 10. Random area is a floating point number, and we could use 10 as well, but we can write 10f as this is a floating point number. And in our loop, we can reduce this, we can change this 10 to cube amount. And these ones, okay, instead of minus 10f and 10f, we use minus random area and random area. Okay, and after that, we can just copy this line for x and paste here on y. So it's going to look like this. And now if we save and go to Unity, we can customize that in our game controller. Okay, so cube amount, let me increase that to 15, and in random area I'm going to use just 5 units. Okay, and we can press play, and we have 15 cubes in here. Okay, and if you play again, every time the cubes are going to be in a different position and a different layout. Okay, so that's pretty much how the for loop works. There is another way that you can write this. Instead of using a for loop, we can use the while loop. Okay, so it works pretty much like the for loop, but we have to do more things manually. The for loop is like a wiser while loop. So a way to rewrite this block with the while instruction is to type here int I equals to 0, then while y is lesser than cube amount, then we do whatever is being done here. Okay, so let me copy that and paste here, and in the end we type I++. Okay, I'm going to even remove this from here. Okay, so let's take off these lines. I'm going to save this, go to Unity, and we're going to take a quick look on this soon. Okay, so wait for the compilation to complete. We're going to press the play button, and we have the exact same effect. Okay, we have 15 cubes in a random area of 5 units. Okay, it's interesting to rewrite this because you're going to, it's kind of, while it's not very good to, well, just rewrite what we just did, but it's interesting because it's easier to read actually. So we declare a variable that is going to simply count where we are currently at. We have a condition that we check if it's being met, okay, and while this condition is being met, we spawn a cube, and in the end of this, we increase, well, we do something. Okay, in this case, it's just increase the counter that is stored in the I variable. Okay, so that's pretty much a way to do the for loop. And again, there are other ways to perform different loops. Okay, you can, for instance, use a do while loop. Okay, you're going to perform something. You're going to perform an instruction first, and later check if it's the condition is being met. Okay, this is very useful for a few situations, but in general, if you use for or if you use while, it's going to work just fine. Okay, and there's another loop that is interesting, is to use the for each loop. Okay, you can loop inside an array of variables, but that would be a subject to another lesson. Okay, anyway, if we save this script, if we go back to the for loop and just go to Unity and wait for this compilation to complete, we have pretty much finished our introduction to coding in Unity. Okay, so we've covered the usage of variables. We can see these variables here in the editor, and we've dealt with numbers, strings, we've dealt with Boolean variables, we learned how to create methods, use methods. There was a lot to cover here. So even though this was a quick class, just around 1 hour, we've covered different concepts, and these tools that you just learned are going to be essential for making your games, okay, for making your games right and for making them quick. It is important for us to start simple so we can later evolve to something that is going to be awesome and is going to be in the store and probably going to be a hit in the future. Okay? So I hope you enjoyed these lessons, and I hope to see you in the next videos.